to introduce our Sustainability Manager, Marian Garfield, she's Director actually, who is going to take us through our commitments and progress to date.
So thanks, Andy, and good morning. As Andy has just mentioned, my name is Marian, Director for Hanson UK. Dr. Kim, Heidelberg has some very challenging goals, and within the UK, Hanson have also set ourselves some ambitions within our 2030 commitments. These areas that we covered within the 2030 commitments match those of Heidelberg Group in the sense of we cover health, safety, business innovation, environmental responsibility, resource use and a circular economy, being a good neighbour, and fairness, inclusion, respects. And as we all know, sustainability is a wide-ranging topic, and I think today is all about collaborating you as our stakeholders and really talking about and how we can reach the goal of net zero. So our commitment as Hanson UK is to be net zero by 2050. And I think it's quite important. So what does that actually mean? What do we mean by this? So net zero means balances of carbon. It's either removed by also eliminating it from our processes. And as you can see, this target isn't a woolly target, and all of our 2030 commitment targets have all been officially recognised as science-based targets, and also they are aligned with the United Nations Sustainable Development Goals. So although we've got some big ambitions, it's also worth remembering that we're not starting from scratch on our journey to net zero. We have been working on reducing our emissions for decades and have already made some significant progress. A few minutes ago, Stuart gave an excellent tutorial around the challenges we face as an organisation and showed us how the manufacturing of cement makes up the vast majority of our CO2 burden as an organisation, 90%. And let's be honest, the chemical process of converting limestone to clinker releases CO2. It's inevitable. So if chemistry can't be changed, and how have we in the past, and how will we in the future reduce our emissions from the manufacturing cement? So let's talk about the progress we've made to date, and let's talk us through sort of a timeline of what we've done since 1990. So let's use 1990 as our baseline. You may have heard in the past that a tonne of cement releases about a tonne of CO2, which isn't entirely accurate. The actual figure was about 941 kilograms per tonne of cement. So in 1991, we did two things as a business. Firstly, we closed the Pitstone cement works, and the reason we did this is it was a wet process that we used, which was using, and it was very inefficient in the sense of we were basically liquefying raw materials for transport to our kiln, and then using more fuel to dry it before it was being converted into clinker. And secondly, in 1991, alongside this, we introduced a new fuel type to our kiln in Ribblesdale called Semfuel, which is made from solvents, which are waste products from other industrial processes. So a few years later, in 1995, we saw our capacity to manufacture GGBS, a cement replacement, increase significantly through our acquisition of Civil Marine, and I think Nina will talk about more about this later on in the programme. In 2000, we again reduced our reliance on coal to fuel our kilns by introducing our first use of 100% biomass fuel. This biomass is another waste product from the meat industry, but it's considerably lower carbon in comparison to the coal that it replaced as a fuel. 2005 was a big year for us, with a new kiln being commissioned at our Padeswood Cement Works and the closure of the remaining wet process kilns that I mentioned earlier. So these improvements in our process between 1990 and 2005 resulted in the baseline of the 941 I mentioned earlier, reducing by 140 kilograms to about 800 kilograms. So a significant drop. In 2006, we again focused on fuel. that were used in the cement kilns. We commissioned a pro-fuel facility at our Ketton cement plant, and this type of fuel is partly biomass, such as paper and plastic. In 2010, around a third of our cement was supplied to our customers in bags, predominantly by building merchants, but still a significant volume. And what we did here was we changed the type of cement that we put into the bags from a CEM 1 to a CEM 2, which means, in basic terms, some of the clinker was replaced with raw limestone. And this gives it similar properties to the CEM 1, but it's got a much, much more reduced carbon burden. And alongside these changes at Cement Works, we also increased the proportion of cement replacements, primarily the GGBS, that we use in our concrete. And I'm sure Nina will explain this more later on in her session. In 2018, in line with the Paris Agreement, and Dr. Kim mentioned it earlier on, Hanson also developed our very first science-based reduction targets. And in 2019, alongside Heidelberg Cement, they set their ambitious target for net zero by 2050. And just last year, and Simon mentioned it in his introduction, in 2020, we were the first company to trial a net zero carbon fuel mix at our Ribblesdale Cement Works. And I'm sure that Ian will go into this in a lot more detail in his session later on the agenda. So all of this work has reduced the carbon per tonne of cement by a further 307 kilograms. So what does that mean? So all of our work between 1990 and now has seen us halve the amount of carbon and bring us to our latest baseline figure of 494 kilograms of carbon per tonne. So the majority of what we've done and been focused on in the last sort of 3 decades has been around fuels, which Andy explained earlier contributed to about 36% of our carbon emissions when we talk about the manufacturing cement. So the big question we ask now is, how are we going to get from the 494 down to the net zero challenge by 2050? So we've got three key levers that we can use as a business. So the first one, carbon capture and storage, where we prevent the CO2 which is released in the process from being emitted into the environment. The second one is switching our remaining kiln fuels to carbon neutral ones. And the third one is reducing the amount of clinker used in our cement in terms of our product portfolio. Now, carbon capture and storage and fuel switching are both massive projects for us in terms of the scale, the scope, and the experience that we've got. So I'm going to now hand you back to the studio and to Andy, who will hopefully introduce our next speakers, which will go through those 2 projects in a lot more detail. Thank you very much for listening, and I hope you enjoy the rest of your day. Over to you, Andy, back to the studio.